Today what we're going to be doing is we're going to be looking at servos, doing some bench testing with that to determine the torque output that we've got, and then working with Excel to help it be more predictive with the way we design with the use of them. So right off the bat, when I'm working with this, I'm going to try to find a data sheet that I'm able to reference. And so I've got this one for the SG90, which is the one I'm working with today. I'm going to go down. I've got specs as far as the size. I've got the torque output, which is in kilogram centimeters. I'm going to be working in gram centimeters. And then I can see that my voltage here is 4.8 to 6. I'm going to only be able to supply 5 volts. And so we might see some variances that are pretty substantial. I'm then going to take the data from my data sheet there and apply it into this Excel table, which records like the name of the motor, the voltage I'm going to supply, the stall torque, the pulse widths that we have to send to the Arduino. And then I'm going to try to make a good guess as far as how I want to test this. And so I've got a 4 centimeter arm that we're going to be working with. I'm going to have a mass of 200. And if I look down here, I've got conditional formatting from my stall torque to show that I should be able to get to somewhere around 600, 650. But experience shows that we're going to have significantly less. So I'm actually going to start at 200 and see where we're able to get and calculate with my setup the torque that we're able to pull out. I'm going to work with Matlab to complete my testing. And so I've got identifying my Arduino, finding both of my servos. I've put my pulse widths from my data sheet directly into it. I'm then coming down here and I'm writing a code that is reading buttons. And if it reads the button press, it's going to turn one of my servos. If it reads the other button press, it's going to turn that. And then I've got a third digital read here off the button that allows me to stop my code. And so I'm able to quickly jump between the two or end my code, which is really nice. We're going to do some easy bench testing. And so I have both my motors mounted here. They're both the SG90 from Vilrose. On front of them, I've got laser cuts that are constraining the rope coming down 2 centimeters from the center point on the motor and 4 centimeters on the motor. There is some inaccuracy in this because we're not really taking into account the weight of this head, and we're going to run into some voltage problems with the signal from the Arduino and Matlab. So I put 200 grams on my 4 centimeter wheel. And what we're going to do is we're going to lift up on it, and once it lifts up, I'm going to pull my hand up to sort of catch the weight, coming back down. That's what's going on. We're going to do 220 grams. Do the same thing here where I catch it. And now we're going to do 240. And it stalls out. All right, well, let's apply that data back to our Excel table. What I'm seeing is that my 4 centimeter arm on that is going to be right around 220 as far as our force, 240. And so I'm going to modify this to where it goes up by 10 in comparison. And we'll use this number of 880 to set our torque for. And that's just for this experiment, right? If we had a lighter wheel on the end or if we had different setups, we're good to go. I've already got applied down here. And so I want to lift, if I want to lift a mass of 250, what this conditional formatting is doing is telling me what the arm length would need to be there. And so let's use this to be able to calculate with our torque input of 880, what we should be getting out of our arm length that is 2 centimeters. And so if I do that, right here is my 2 centimeter length, should be able to lift around 440. Notice very quickly that this is going to drop drastically as the additional distance is added. And so the shorter I can keep my moment arm, the better I'm going to be off. So now we're going to look at our 2 centimeter wheel. I'm going to lift it. Let's see if it works. Cool. I'm going to add it, so I've got 400 grams now. Able to lift it. Struggling a little bit. So we can get the truly stall out all the way. So we're losing a little range of motion on it, right? And I want a spot. All right. So now we're able to sit there and have a mindset that we'll get around 880 gram centimeters or more if we go with the test that we just did, and apply that data back to our projects that we're working on. Are we going to design things to have that 880 gram centimeters force like as a cap, or do we need to design things that are a little bit with less torque on it so we can be more assured that we're going to have safety of our servo motor? And that's really up for you as far as a designer to make that happen.